Hi Honors Algebra 2 students. I wanted to do a quick video on functions. So some students have told me that their Algebra 1 class, whether you come from a different school or even at Harker Middle, maybe didn't cover functions as in depth as we, expect for Algebra 2. So I wanted to make this extra video just kind of going through functions again, saying something about domain and range and helping you with the notation. Okay, so as we know, and we talked about this a lot, a function is a correspondence between two sets that assigns to each element in the domain exactly one element in the range. There are some examples here. You can write a function as a set of ordered pairs. So this function only has 4 points. There are 4 input values, 1, 2, 3, and 4. And there's 4 output values, 3, 3, 6, and 4. Or 3, 6, and 4. Because 2 of the inputs give you the same output. There's different notations our book uses for functions. Sometimes they'll use equations, where the input is x and the output is y. Sometimes they use f of x notation. This is simply an alternative. The advantage to the f of x notation, excuse me, I'm sorry. The advantage to the f of x notation is that you can easily notate plugging certain numbers in. So f of 2 means to replace x with 2. And then you get a value. So in this case, we would get 4 plus 3 is 7. There's also a mapping notation. This says that your inputs x turn into 2x plus 3. We'll see that in the future occasionally. You can also describe the function as the set of all ordered pairs such that y equals 2x plus 3. So any ordered pair that satisfies this equation is an ordered pair in the set. Okay, now we also talked about domain. Domain is the set of all numbers that you can plug into the function. And in our case, we generally have x as our input, but sometimes we'll see t or d, but we have one number we put in and one number we get out. In this case, we're assuming that a, b, and c are all constants. Any constant, they can be any constant. So a, b, and c could be any real number. And when you have a quadratic equation like this, you can plug in anything you want because you can square any number, multiply it by a, take that number, multiply it by b, and sum up these 3 terms. And you'll always get exactly one number out. So the domain is all real numbers. We had a shorthand notation for that, all real numbers, and an interval notation, all real numbers, is negative infinity to infinity. If you wrote any one of these 3, I would take it. Okay, this one, what's the domain of g of x? Well, we're only dealing with real valued functions, so we only want real numbers out, no i's, no complex numbers. We'll do that later in chapter 7. For right now, if I plug in, for example, g of 1, I get the square root of 3 times 1 plus 5, and that is the square root of 8. The square root of 8 is a positive number. It happens to be irrational. You can reduce it to 2 root 2, but the point is I can plug in 1 because I get a number out. So 1 is in the domain. What's an example of a number that's not in the domain? What about g of negative 2? That would be square root of 3 times negative 2 plus 5 equals square root of negative 6 plus 5, or square root of negative 1. We can't take the square root of a negative number and get a real number out. So negative 2 is not in the domain. So how do we express all the numbers that are in the domain? I'll switch to green. Let's just emphasize something for a second. 3x plus 5 is underneath the square root. You can only take the square root of positive numbers or 0. So 3x plus 5 cannot be negative. In other words, 3x plus 5 needs to be greater than or equal to 0. Well, what is this? Negative 5 less than or equal to 3x. X is greater than or equal to negative 5/3. There's our domain. Our domain is the set of all x's that are greater than or equal to negative 5/3. In interval notation, that would be everything from bracket negative 5/3, comma, infinity. our book would write it the set of all x such that x is greater than or equal to negative 5/3. Okay. All right. What about this one? Well, we have a couple issues. First, you can't divide by 0, so x cannot be 1 and x cannot be negative 1 because that would cause you to divide by 0 in the denominator. But we also need x to be non-negative. We need x to be greater than or equal to 0 because we need to be able to take the square root of it up here. So if you think about it, this condition precludes this possibility. It's not possible for x to be negative 1 and greater than or equal to 0. So we can ignore the concern about negative 1. If we were to graph this domain, negative 1 would be here, 0 would be here, 1 would be here. X can be any number from 0 up, except we need to skip 1. X cannot be 1, but x can be any other positive number, and x can be 0. So one way to, if we were to graph it, here we go. One way to express this is interval notation. Everything from 0 to 1, union, everything from 1 to infinity. There you go. The textbook would put the set of all x such that x is greater than or equal to 0 and less than 1, or since it's a disjunction, or x is greater than 1. I never will require you to use this notation. I personally think that graphs and interval notation is a lot simpler. So, but you can answer with any way you want as long as it's clear. Okay, composition of functions. Some students had questions about this. If I have f of g of 0 and f of x equals this and g of x equals this. First off, what is g of 0? Because I noticed that I have g of 0 on the inside here. Let's figure that out. That means you take the g function and you plug in 0. And we get negative 5. So f of g of 0 is the following. I'll do it in green. F of g of 0 equals f of negative 5, because g of 0 is negative 5. Well, what's f of negative 5? I just plug negative 5 into the f function. 2 times negative 5 plus 3 equals negative 10 plus 3 equals negative 7. That's it. It's just a matter of unpacking the definitions from the inside out. So this one is g of, now 1 over, now we want f of 0 in the denominator. F of 0 is 2 times 0 plus 3. And that equals, so we have g of, and that will be 1/3. And g of 1/3 is, now we just need to put 1/3 into here, which is putting 1/3 into here. And g of 1/3 is negative 1/3 minus 5. And if we just, get a common denominator and add that together, it'd be negative like 15/3 here. So we would get what? Negative 16/3. I know you can add fractions. I'm more worried about the function notation. What's the domain of 1 over f of x? Well, 1 over f of x, it's helpful to write it out. 1 over f of x is 1 over 2x plus 3. And therefore, we do not want, what we don't want is we don't want 2x plus 3 to equal 0. Because if that were true, you'd divide by 0, and that would be impossible. It's undefined. But let's take a moment and put an equals here, and let's solve for what value gives you that problem. 2x equals negative 3, x equals negative 3 halves. So the domain is all real numbers except negative 3 halves. If you just wrote out the sentence I just wrote in English, I'd take it. If you graph it, it would look like this. Negative 3 halves. We don't include that. The domain includes everything else. In interval notation, that would be everything from negative infinity to negative 3/2, not including 3/2, union everything from negative 3/2 to positive infinity. Okay. On these kinds of problems, you just need to be careful and slow. So I'm going to write my g function down here so I can see it. G of x is equal to negative x minus 5. Okay, so g of a plus h, well, what is that equal to? That's this expression here. G of a plus h is, well, wherever there's an x, I put a plus h minus 5. And that is negative a minus h minus 5. So g of a plus h is negative a minus h minus 5. Okay, what is g of a? G of a is negative a minus 5. So now let's do this whole expression. So I've got my two pieces here. G of a plus h minus g of a all over h is, what is g of a plus h? It's negative a minus h minus 5. Let me make that a little nicer, minus h. I find it helpful to put parentheses or brackets around these big things you're plugging in to keep track of everything. G of a is here, and this is this, and that's what goes here. Let's plug that in. Negative a minus 5. The brackets or the parentheses, brackets and parentheses are interchangeable. It's just a visual thing. It helps, if you have it, it helps you remind you to distribute the negative. I got to make sure to have my over h here. Can you see that negative a minus negative a is cancels? Negative 5 minus negative 5, that's 0. What am I left with in the top? I'm left with negative h over h. This is negative 1. The answer is negative 1. All right, that was just a quick review of functions. Wanted to help you with the notation, a little bit about domain. I'll see you in class.